Hello everyone, my name is Fidel Montiel and today explain my poster to talk about of the quality analysis and hardness distribution of a 304 stainless steel welded plates. Okay, it's important that you know that in the welding industry, the joining of the stainless steel plates is a fundamental process for the fabrication of durable and reliable structures and components. The proper selection of welding parameters, such as bevel angles, amperage, and speed, is crucial to ship a high quality and high strength joint. In this study, three different stainless steel plates were analyzed in order to evaluate the effects of modifying angle uh, and as welding parameters such as amperage and speed. The samples were joined using the gas metal arc welding GMAW technique, which is widely used in the industry application due to its efficient and versatility. In addition, comprehensive macrographic, microhardness, and micrographic analysis were carried out on the welded samples. The macrography allows examining the general structures and of the weld zone with the naked eye, providing valuable information on the surface appearance. In this part, I'm see the homogeneity of the sample. Um, in the distribution and general characteristics of the joint. On the other hand, the microhardness analysis is used to evaluate the hardness in different regions of the weld zone, providing quantitative data on the mechanical properties and resistance to plastic deformation on microscopic scales. In addition, micrography obtained by metallographic techniques allows the microstructure of the weld zone to be observed and analyzed in revealing precise details about the phase and distributions. The presence of inclusions, grain information, and other crucial aspects that can affect the joint properties. Detailed analysis of the welded specimens included micrographic, and micrographic evaluations will allow you to gain a comprehensive understanding of the effects of bevel angles and welding parameters on the quality of stainless steel joints. It's important to emphasize that the main objective of this study is to provide a comprehensive and detailed view of the effects of bevel angles and welding parameters on the quality of stainless steel joints using a combination of macrographic, micrographic, and micrographic analysis. These results contribute to the development of more efficient and reliable welding practice in various industrial applications because you can see the stainless steel in much places. For example, in my kitchen, I have a bar of the stainless steel. There's 304 on the restaurants or in many places. You can see the this stainless steel, and it's important this is the results for contribute the development. Naveen Josh studied the quality of the EMAW by varying the welding current and the distance between the nozzle and the weld. And we conclude that the best joint was with 112 amperes and a distance of is if 20 millimeters. In the same way, Moh Aslam and Chimaya Kumar Sahu studied the welding parameters for the EMAW process on IC 304 stainless steel and found the voltage as the main parameter in bed quality. The methodology of this study is based on the and used different parameters of the in the samples. The parameter of sample one, call it M1, are at a 30 bevel angle, the second one 20 bevel angle, and the last one 15 bevel angle. And the variations of parameters that I change is current, voltage, and the speed of the arc. When analyzing them in a macrographic way, we obtain the tags as the measurements of the welding point where is what possible to identify that the welding is perpendicular to the plates. And in the same way, it was observed that in M2, the joint is homogeneous, and you can see in the pictures and of the poster, the the joint is homogeneous, and in the M2, I'm pointing in the the pictures. In this part, you can see that the sample is completely homogeneous, but in this and these images, you see and the it's not homogeneous because in this part it's not a good fashion fusion. Um, and in the micrographic samples is where this was possible to observe in detail the behavior of the weld as well as the phases of steel 300 or as astenite and ferrite, which was identified in the three samples to the fact that in the Aquarella attack, and we see equidistant lines as you can see in these images, and I emphasize with color blue and in color blue. The hardness traverse that the test showed for each one can be seen in the following graphs. The hardness does not change much. An average of the three was taken, and it was seen that sample 2 has very little a higher hardness. But the the M2, you can see uh, you can see the rank and no significant comparison, but in the M2 is more hardness. And in the modification, I'm conclude that the modification of bevel angles influenced the quality of the welding joint. It was observed that wider bevel angle resulted in more uniform stress distribution and higher resistance to defect formation, such as cracks and porosities. Welding parameters such as amperage and speed had a significant impact on the hardness of the weld sound. It was found the higher amperage and higher welding speed resulted in the higher hardness, while lower values generate reduced hardness. Micrographic images reveal the presence of phase such as stenite and ferrite. This finding highlight that the importance of proper selection of bevel angles and welding parameters on the quality and hardness distribution of a 300 for stainless steel welded plates. The results were also compared to previous research, allowing use to validate our findings and contributed to the exciting new knowledge in the field. The results obtained support the importance of optimization welding parameters to achieve high quality and high strength joints in the industrial application. This knowledge can contribute the improved welding process and promote more efficient and reliable utilization of stainless steel in various fields. Um, the D1.6 standard established tolerance and specific requirements for the analysis and testing of welds. And so compared with these studies based on this standard, it was possible to find coincidence of results in them. And the best conclude is that the sample 2 is the best joint and has a better or more properties based on the studies that I mentioned later. Uh, the the simple view use 20 grades of the bevel angle, and this is the best option that you choose for use yours for use welded plates. And it's allowed. I feel Edel Alejandro, and it's good to contribute that this information for yours. Nice and good.